Okay, these are the solutions for today's quiz and for last night's homework. So this was the quiz question, and the first thing you needed to do was to find the derivative. So these are pretty simple. You should get that plus that. Remember, 1 over x is the same thing as x to the negative 1, so it's going to be negative x to the negative 2. And if you simplify that a little bit, it will look like this. Okay, so that's simplified, and now we had to find it when x was negative 1. So negative 1 squared is 1, and 1 times negative 3 is negative 3. And you get 1 over 1, which is just 1. So the 1 and the negative 1 cancel, and you get negative 3, and that was choice D. Okay, this was from last night's homework. I'm sorry this is a little bit blurry, but basically this is your question, and so you have to try all different kinds of things here. So first we're going to do the left Riemann sum. So let's just say that, I don't know, you've broken it into an interval here. If you take the left Riemann sum, it's going to look like this. So a left sum is going to be an underestimate. So that's under. Okay, if you do a right sum, and again, just if you take it from, over here at 1/2, I hit this. If I do a right sum, I'm an overestimate. And now if I do a trapezoid, I'll do it again from here. So I have a point here and a point here, and I draw my line, and you can see my trapezoid is an underestimate. So the question is asking which would give an underestimate, so it's going to be a left sum, number 1, and number 3, and that was choice D. Okay, here's the next one. And so we're told that you need to find the area under the curve using 3 subintervals. So the first one's going to be from 0 to 2. That came from right here. The next one's going to be from 2 to 4, which came from here. And the next one's going to be from 4 to 6, which came from here. Okay, so we're using a trapezoid. So we're going to have 1/2 for each. Okay, so base 1 is going to be 4, plus base 2 is k. Okay, for the next one, now base 1 is k, and base 2 is 8. For the next one, base 1 is 8, and base 2 is 12. So what is the height? Well, for all of these, they go up by 2. So the height is 2. I can't put the 2 in there because there's a little thing there. Okay, I'm going to put the height here. 2, 2, and 2. Okay, so you can see that this cancels, and this cancels. So we're left with 4 plus k plus 8, and 8 plus 12, which is 20. Okay, so these 3 pieces will make up the area under the curve. So if we add them together, we get 32 plus 2k. But we know that it has to equal 52, because you were given that. So if you subtract 32, you get 20, and therefore k must equal 10. That was choice D. Okay, so for this one, the goal is to find the area of f of x from 1 to 3. But we know that f of x is equal to g prime of x, so I can substitute g prime of x for f of x. Okay, so if I take the antiderivative of g prime of x, what came before? G of x, as it goes from 1 to 3. So it's going to be g of 3 minus g of 1. So what is g of 3? Well, here's the function right here. So g of 3 will equal 3 squared minus 3 times 3 plus 4. That gives me 9 minus 9 plus 4. So that's just going to equal 4. Okay, so 4 minus, and now I need g of 1. So g of 1 is going to give me 1 minus 3 plus 4. That's negative 2 plus 4, that equals 2. And 4 minus 2 is 2, which is choice C. Okay, and this is the last one, so I'm sorry again, it's blurry. So the area under the curve from 0 to 3 is 6. And the area under the curve from 3 to 5 is equal to 4. So the area under the curve from 0 to 3 plus the area under the curve from 3 to 5 would just be the area under the curve from 0 to 5. So the area under the curve from 0 to 5 would just be 6 plus 4, which equals 10. Okay, that's not the answer, but that's for that part. And what we're really supposed to be finding is this. So the area from 0 to 5 of 3 plus 2f of x dx. So when we first learned about antiderivatives, there were a bunch of rules that really weren't so necessary then, but they'd be necessary now. We're allowed to break this up into two different functions. Remember that we had a rule that said that you can break them up into two separate ones? And I said you'll appreciate that one day. Well, now you can appreciate it. Okay, so we're going to do this one first, from 0 to 5 of 3. So the antiderivative of 3 is 3x as it goes from 0 to 5. Substitute the 5 first, and then substitute the 0, and you're going to get 15. So this piece right here is equal to 15. So I'm just going to erase and make some room so we could write that answer. Okay, so we know that the area from 0 to 5 of 3 dx equals 15. Okay, now we have to do the next part. Okay, so this is the next part. So there was a rule that said if you have a constant times the function, you're allowed to bring the constant to the front. Okay, and we get that. So let's look at this piece right here. Well, at the very beginning, didn't we say that the area under the curve from 0 to 5 of f of x dx equals 10? I mean, I erased that, but that's what we had at the beginning. So we have 2 times this piece here, which is 10, and 2 times 10 is equal to 20. Okay, let's go back. So that means this piece right here, this is from 0 to 5 of 2f of x dx, that one equal 20. So we're just going to add 15 plus 20, which gives you 35, and that was choice D, and that was it. And I'm going to go make dinner now. I'm having shepherd's pie tonight.